Module outputs. A common failure appears when the child module creates a resource, but the root module tries to read that resource attribute directly. Terraform rejects that because resource addresses inside the child module do not exist in the root module's address space. A module boundary hides internal resource names unless the child module exports a value explicitly. Module outputs are the only supported way to move selected values from a child module into its caller. By declaring an output, we promote one value across the module boundary without exposing the child module's full internal structure. A child module can contain many resources, but its caller only sees declared inputs and declared outputs. This causes the module to behave like a stable interface rather than a transparent folder of reusable code. When you add an output block, Terraform evaluates the expression inside the child module and records the result as part of the module instance externally visible data. The root module can then reference that value through module.name.output. This keeps internal resource addresses private while still allowing selected facts to cross the boundary. Terraform state does not flatten all child resources into the root module's visible namespace. State preserves module paths so Terraform can track which objects belong to which module instance. An output does not duplicate the resource. An output creates an exported value derived from existing state data or planned values. During planning, Terraform traces the output expression back to the reference resource attributes. During apply, once the provider returns final values, Terraform stores the evaluate output so the caller can consume it deterministically. Without outputs, callers become tempted to duplicate logic, guess identifiers, or break encapsulation by restructuring modules incorrectly. Outputs prevent that by turning hidden internal facts into deliberate exported facts. This reduces coupling because the caller depends on the name interface instead of a specific internal resource label. If the child module later renames a resource internally, callers do not break as long as the output name and meaning stay stable. Output names therefore become part of the module's public contract. Outputs should expose values that downstream configuration generally needs, such as IDs, ARNs, names, addresses, or policy references. Outputs should not expose every attribute just because Terraform can read it. Over-exporting increases coupling because callers begin to depend on details the module author never intended to support long-term. A small output surface makes refactoring safer. A precise output surface also makes module reuse easier because consumers can understand what the module promises without reading every internal resource block. If the root module tries to reference aps.vpc.main.id directly, Terraform fails because that address exists only inside the child module. By declaring output vpcid inside the child module, we export that internal value across the module boundary. The caller then reads module.network.vpcid, which is the only valid public path to that value. This causes the caller to depend on the child module's interface instead of its internal resource labels. Terraform evaluates the child output expression against the child module's graph. then exposes the result to the caller during planning and apply. The state file keeps the actual resource under the child module path, while the exported output gives the caller a supported reference point. This separation prevents callers from coupling themselves to internal implementation details. If the child module later renames aws_vpc.main to another internal label, callers still work if output VPC ID continues to expose the same semantic value. That is why outputs are not cosmetic metadata. Outputs define what the module promises to the outside world. In a submarine, one compartment reports the information another compartment needs, but it does not expose every valve, wire, and control path inside that compartment. That separation limits confusion during casualties because operators act on trusted interface data, not internal assumptions. Terraform modules work the same way. If you expose too much, downstream code starts steering against internal details it should never control. That increases blast radius during refactors because one internal rename can break multiple callers that were never supposed to know those internals.